to the Talentrix channel. Talentrix, we driven to explore talents from students in podcast industry. Do listen our audio-visual blogs in Kannada, English and in Hindi. Do subscribe and press the bell button for regular updates. Dear friends, today's topic is sound and waves. My dear friends, have you ever thought about how your sound travels and reach another ear? Now, today Shreyas, our student of Adarsha Balika School in Dharwad, he briefly giving interesting information about sound and waves. Let me go with Shreyas.
Hello everybody, Shreyas are here. I'm studying in 9th standard in Government Adarsha Vidyalaya, Keri, Dharwad. Many of the listeners here might love music. I would like to ask you what music actually is. Today, I am here with a new topic, sound and waves. Before discussing the topic, I have an interesting activity for you. Take a rubber band, stretch it and pluck it with your fingers. You will hear a sound while plucking the rubber band. Have you ever wondered how this sound is produced? Observe the rubber band carefully. Can you see the string continuously moving forward and backwards for some time very fastly? This continuous to and fro motion is known as vibration. These vibrating bodies, such as rubber band, creates a form of energy which we call it as sound. Simply speaking, sound is a form of energy produced by vibrations. The music we all love is also the sound produced by various instruments and humans. The sound travels at an amazing speed of 343 meters per second. It is as fast as airplanes. Pretty cool, right? As sound is so enjoyable, it is also very dangerous. The high intensity sounds above 150 decibels can burst your eardrums, and the sounds above 185 decibels can impact your inner organs and cause death. Sometimes sound is also used as a weapon in military. These weapons are known as ultrasonic weapons. When a body vibrates, it creates sound waves which travels through mediums such as air, water, etc. Unlike light, it cannot travel in vacuum, which means a medium is necessary for the sound waves to travel. Can you guess in which medium does the sound travel fastest? Yeah, you got it. Sound travels the fastest in solids. There is actually an explanation for this. As the molecules are closely packed together in solids, the sound waves travel faster than liquids and gases, as their particles are loosely packed. When the body vibrates, it causes movement in the particles of the medium. This movement is called as sound waves. It keeps on going until the particles run out of energy. You might ask me, what type of wave is a sound wave? I would say they are longitudinal waves. In this type of waves, an object which is producing these waves do not move from one place to another. Instead, it simply oscillates forwards and backwards, and then comes to rest in its original position. In the activity we did earlier, the rubber band did not move from one place to another. Instead, it just oscillated to and fro and then came to rest at its original position. This type of waves is nothing but the longitudinal waves. Actually, there is a property of sound which might shock many of you. Just like light, the sound waves also experiences reflection. It might be hard to believe, but trust me, this is true. The light bounces back after hitting a shiny surface, but the sound bounces back after hitting a hard surface, causing reflection of sound. The laws of reflection of sound are exactly similar to the laws of reflection of the light, which I discussed in the previous podcast. Now, it might give you a clue about what echo is. Echo is the repetition of sound caused by reflection of sound waves. It arrives at the listeners with delay of direct sound. If the gap between the original sound wave and reflected sound wave is greater than 1/10 of the second, that reflection will be called as echo. The bats and dolphins use echo to detect obstacles and navigate their prey. Echo is also used in sonar technique or sound navigation and ranging technique to detect the submerged objects such as submarines, icebergs, etc. Echo is used in various objects such as stethoscope for hearing sounds of inner organs, megaphones to increase the intensity of sound, soundboards to increase the intensity of sound in a particular point, hearing aids, etc. To make this more clear, let us take an example. In an empty room, the time for reflection delays as the hard surface is far from the source where noise is coming, resulting as echo. But when the room is full of objects, the reflection takes place very fastly, so there would be no echo. Now, let us look into some of the properties of sound waves. Firstly, low-pitched sound has lower frequency and high-pitched sound has higher frequency. Here, frequency means the number of oscillations in an unit time. Frequency is represented in hertz. Next, soft sound has small amplitude and louder sound has large amplitude. Amplitude means the energy of sound waves. We also must know what a wavelength is. The distance between two successive crests or troughs of a sound wave is known as wavelength. Sound waves can also be defined as periodic compression and rarefactions of an elastic medium. Compression means the molecules in the medium being pressed together, whereas rarefactions means the molecules in the medium spread apart. Finally, we would see how humans hear sound. We have an extremely sensitive organ named ear. The outer ear, pinna, collects the sound from the surroundings. The sound collected is passed through the auditory canal to a thin membrane called eardrum. When compression of the medium reaches eardrum, it moves inwards, and when rarefactions reach the eardrum, it moves outwards. Like this, it vibrates. These vibrations are amplified by three bones named the hammer, anvil, and stirrup several times in the middle ear. It transmits amplified pressure variations to inner ear. Inner ear turns pressure variations into electrical signals by the cochlea. These electrical signals are sent to brain through auditory nerve, and brain intercepts them as sound. So all this process takes place within fraction of seconds. So amazing, right? So finally, in this podcast, we looked into the meaning of sound, properties of reflection of sound, meaning of sound waves, properties of sound waves, about echo, uses of echo, how humans hear sound, and many more. In the next podcast, I will be back with another interesting topic. Until then, thanks for listening.
My dear friends, I hope you all liked today's video. Then see you again in the next video with another new topic. Thank you. For more updates, do visit www.talentrix.co.in.